Okay. Picking up where we left off, this is Master Carpenter Series Part 7. And what we're doing here is picking up where we left off at. Now, we have an overhang of 16 inches, but our hip sits in 11 and 11.447 inches. All right? We have to add these two together. Why? Look at this. Because you have a triangle here, okay, that includes this little dotted line. So if you look here this is the tip of the triangle. I'm tracing it so you can see it. That's that triangle. So what we need to do is add this together, and this is going to be like the run, okay? This is going to be this line from here to here is going to be the run of this little triangle that's in here. All right, now let's do that. We got 11.447 plus 16 equals, all right, which is 27.444. So we know from here to the outside of the subfascia, to the center of the hip, and where it intersects with the building line is 27.44. That's exact measurement, y'all. That's exact measurement. Now, we know that from here to the outside, from ink line to ink line, the darkest line, is 16 inches. So what we're going to do is divide this length by 16 inches. So in other words, this length is going to be divided into 16 sections, which is this number. So divided by 16 equals. So that means for every 16 inches, for every segment of 16 inches, this line here is broken up into 1.715 inches. And notice this, y'all. Watch this. Notice that measurement is the same as this one, basically. I got 1.714, 1.714. All right? So now that we have divided that by that, now that we divided this part of this triangle, which I will label that the run, by this part of the triangle, which I'll call the rise, even though it's upside down. Now what we want to do is we want to see what angle that this comes on. And the way that you do that, you just press the second function, or the inverted tangent, and you invert the tangent, and you get 59.67. We have the 59.67 degrees there. Okay, make sure all this is marked properly. And then 59.76 degrees minus 90 equals 30.23 degrees. So all the rafters on this side, which are the 712, which go on this side, they're going to go from the wall plate up to the hip. The bevel that these rafters are going to have on them is 59.67, basically 60 degrees. The 1212 side is going to have the shallower bevel on it, which is 30.23 degrees. Now watch this. Let's do this over. I want to recall this because I know it's stored in here. And this number here is this number added together, and now we're going to divide it by 16 again. Divided by 16 equals, okay, 1.175. Okay, we're going to find the degrees again, invert the tangent. We get to 5967. Now watch this. we're going to press the cosine button. Okay. And then the 1 inch segment is the best way I could describe this number. And so this 1.8, 1.985. Now, 1.985 is the degree angle per inch. So for every inch of degrees, the length of it is almost 2 inches. All right. And that's the run. That's the run. This measurement right here is us looking down at the run. If we're standing over the run, we're looking down at the run. So from here, outside of sheeting, all the way to outside of subfascia. Okay. And what we do is we take this measurement and multiply it times 14.5. Now you say, why 14.5 and not 16.5? Because see, this hip is going to hit to the inside of the subfascia. It's not going to hit to the outside of the subfascia. The subfascia is going to run on the outside of the hip, and the hip is going to run to the inside of the subfascia. So, and the difference is from 16 inches minus 1.5 inches is 14.5. So from here to this first line here is 14.5. So I'm going to multiply this number times 14. 0.5. 14.5 actually equals 28.79. Now I just drew this out. This is like the side view of the hip overhang, so you could just see it from the side. This is the top view, just looking down on it. This is looking at it from the side. So the run for that is 28.79. All right. Now what you want to do is take this 28.79 and divide it. We want to divide that by 16.97 because all hips run on a 90-degree corner. A house with a 90-degree corner is going to be 16.97 equals. Okay, so we're going to do this 1.696, and these are segments. This is a segment of 16.97 in segments of 16.97. Just to write that down, we're going to circle this. All right, so we got 1.696 step off per 16.97. I know that's a mouthful. What you do now to get the length of the hip from the center line to the center line, from the center line, inside center, the center line to center line, from building line to the inside of the subfascia, you take that and you multiply it by 19. Oh, I'm sorry. I messed something up here. Yeah. 1.696 times 19. Okay, I did something wrong here. Oh, I think I see what I did wrong here. All right, let's do this over. Let's erase this. This is causing confusion here. I kind of got twisted around here. It's not the best eraser in the world, you know that. So let's backtrack here. So we got we're going to go recall 1. And we know that this measurement is 16 inches plus 11.447. We know that. We divide that by 16. Divide that by 16. Divided by 16 equals, okay, which is 1.715, which is good. That's real close to what we got. Exactly what we got. And then what we do is we second tangent, and that gives us our degrees. All right. Then we do cosine. Cosine. And so that's 1.985. Okay. Times 14.5 equals. Okay, there we go. 28.79. Okay. Now what we do is take the 28.79 we take the 27.79 inches and we're going to divide that by 16.97. Which is 1.69. Okay. So I think I see what's going on here. So this is right. 1.69. And this is 6. And so all that I wrote was right. 16.97. Okay. Now we take this 1.697 and we multiply it. That's how many step-offs we have. 1.697. And we multiply that by 19. Equals. Yeah. So, yeah, this is the one that's wrong here. This is why math is really, really good, because you don't have to recut nothing. You could do this easy just by pushing buttons and maybe erasing. So this the hip overhang for this hip overhang is 32.23 inches. All right. So this right here is the overhang from the building line to the inside of the subfascia. And you can see that the subfascia is going to hit on this side. The hip, the center of the hip is going to be hitting on this, bearing on this side of the inside of the subfascia. You see that? Great. So this is good. This is good. So now we know how long our tail is going to be from inside to inside. Okay. And we already know what our degrees are. We know what these degrees are. The next thing that we're going to do is we're going to figure for a inside corner. We're going to figure for an inside corner. And that's what this dotted line represents, an inside corner. This represents an outside corner. On outside corners, hips go on outside corners. But on an inside corner, valleys go here. This line would represent a valley if it was on an outside corner. And just to show you, I wrote sub here, S-U-B, because this dotted line represents the subfascia for the outside corner. This dotted line represents the building line for an outside corner. You can see really clear here that from here to here, this is the 712 side. So if you got a 712, for the 712 side, the valley is going to sit not on the 12 side. It's going to sit on the 712 side, not the 1212 side. But if you got an outside corner, the bird's mouth for the hip sits on the 1212 side. So you can see these are two intersection points. One intersection point for where the bird mouth goes for the hip, and one intersection point where the bird mouth goes for the valley. You see that, right? And a lot of times what guys try to do when they don't really have this concept down, they'll trace the hip rafter pattern, tail pattern, and they'll take that tail pattern and put it down here. And guess what? That makes your rafter shorter. It makes your rafter shorter. You see, and I want to tell you, and you can see exactly how much it makes it shorter by the distance from the 1212 side on the inside corner to a 712 side on a inside corner to a 1212 side on the outside corner. See, so it's two different bird's mouth, and you can see from here to here is the tail for the hip, but from here to here is the tail for the valley. You see the big difference there? So you can't use the valley, the valleys. Well, yeah, you can't use the valleys on a mixed 12 pitch in the same way because the bird's mouth are in two different places. You can see that. All right. So now let's look at this here. And by the way, I want to show you something else. We know that from here to here, from this mark to this mark is 16 inches. But from here to here, it's not 16 inches. Okay? And we could determine what the length of this one and this one is just simply by deducting 6.675 from 16. And that'll let you know how far the outside of this, from the outside of the subfascia to the center of the valley. You see that? To the center of the valley. And then we could do the same thing and figure out also the tails. Let's just jump into it, stab right into it, and look at that. So we know from here to here is 16 inches, and from here to here is 16 inches. Okay. Now we know that from here to here is 16 inches. So what we're going to do is this: 16. Let's do this first. Let's do this. Yeah, let's do 16 minus 6.675 equals. Okay, so that means from here to here is 9.325. So we're gonna draw a line there. 9.325. Okay, when we add these two together, this measurement with that measurement, is going to give us this measurement, which is 16 inches. Let's just do it for fun. Plus 6.675 equals, you see that? 16 inches. So we know from here to the outside of the subfascia to the center of the valley. Remember, this is the valley bird's mouth. This is where the bird's mouth is going, for the valley. Okay? Because this is actually our wall. The dotted lines are our walls for the valley. Don't pay attention to the solid lines. Those are for hips. But this dotted reverse line is for the valleys. So, since we know Now we got 16 inches here, and we're going to divide 16, which is 16 inches, divided by 9.325. Divided by 9.325 equals, okay, you see, it comes to that at 1.1175. So that lets us know that we're still in proportion, we're on proper degrees and everything else. And to prove that we're on proper degrees, we're going to do the inverted tangent function. Invert tangent, and look what it's going to come out to. 59.76. Same thing. All right. Then what we're going to do is minus 90 degrees, because this is a 90-degree corner. And this is a 90-degree corner. 90-degree corner. Okay. Which is minus 90 degrees equals. Okay, so we got our 30, 32. So we know all of that is right. Now, what we're going to do is what we're going to do is get rid of that minus sign there. And then what we're going to do is do cosine. And we're going to do this function here. And it's 1.174. So what I'm going to do is take this and store it in the calculator. So I'm going to put store 2. So we don't forget that. All right. Now what we're going to do, we are got to figure out what is the difference between this, and we got to deduct 1.5 inches. Let's see. We're going to, I think this gets reversed. We're going to do times, let's see. Okay, we're going to do it. We're going to do this another way to make this easier for me. We're just going to do Pythagoras Theorem. Okay. We're going to do Pythagoras Theorem here, I believe. So let's see. Let's go recall 2. And we're going to multiply this times 9.325 equals. Okay, we're going to do this again. Recall 2 times 14.5 equals. That's the right answer there. 16.78. So that means, look at this. Now this right here is a triangle looking from the side view of the tail pattern. For the hip, we're going to put hip here. But this right here is the side view for the valley. This is the side view for the valley. All right. And we got 16.78. Okay. We're going to divide that by 12 to turn it into feet. Divided by, no, not divided by 12, but divided by 16.97 equals. We got 0.989. Okay, and this, we know this is 16.97 units. Okay, we're going to circle that. Then what we do is we take this measurement and multiply it by 19 times 19 equals 18.790. So from here to here, to the bird's mouth center of the valley, is 18.790. But from here to here, it is to the inside of the subfascia is 32.23. So that right there, and this is for the valley. So this is how you know this is good here. You really and you know what? I think I'm going to do another blow up of this. I'm going to do a blow up of this whole section here. I want to do a special edition after this, and it's going to be the whole section right here and all of this on one sheet of paper, because my paper is kind of crowded, and even though things are still legible right now, I want them to stay that way. But I do want to give you a clearer picture of what I'm talking about. So that concludes part 6 of our series. Part 7 of Master Carpenter Series with Lewis Thomas, discussing mixed pitches and bastard pitches and whatever you want to call them. Okay? All right. Stay tuned for number 8.